Hello students, 8th graders. I am ready to teach you about 8M1 lesson 3. We're going to learn some more about exponents, and we will cut right over to the magic pad and get going with 8M1 lesson 3. So we're learning about numbers in exponential form that are raised to a power. So what you're going to see in the lesson is you see some explanation that we're going to learn a rule that looks like this, and equals x to the mn. So a number, so what does this mean? This means that, and what are some examples? So let's just look at this and see that this means that a number, x, raised to a power, if you take that whole expression and raise that to another power, it is simply, the answer is that number raised to the two powers multiplied together. So what does that mean and why does it work? So first of all, let's just look at some examples. So what would 2 raised to the third power, and we know what that means. We learned what 2 to the third power means back in lesson 1. But what if we took 2 to the third power and then turned around and put that to the second power? Well, let's just break this down. Well, what does anything mean if we raise it to the second power? Well, that means you take what's inside and you repeat it this many times multiplied together. So 2 to the third power squared is simply 2 to the third power times 2 to the third power. You repeat that thing twice. So we're breaking this thing down. So let's go one more time and let's see. Well, if I have 2 to the third power times 2 to the third power, I don't need those parentheses anymore. I can just kind of remove those parentheses. And again, we learned back in lesson 1 that if we take a number to a certain power and we multiply it to that number to another power, we just add those powers, and so we get 2 to the third plus 3. We're just gonna take these two numbers and we're going to add them. We add them together. So we get 2 to the 6th power. So we did that in 2 steps, right? We took our number to the power and we broke it down into what it means to be something to be raised to a power. And then we broke it down into something that we have seen before in lesson 1. And then we found our final answer. Well, if we can keep doing examples like this over and over, so we could do, 4 to the second power. Or let's use the number 5. Let's go 5 to the second power, just to keep the numbers separate, to the 4th. Well, that would be this thing inside times itself 4 times. So let's go 5 squared times 5 squared times 5 squared times 5 squared. Well, that equals 5 to the 2 plus 2 plus 2 plus 2, or 5 to the 8th power. Again, we're just building on, this is just lesson 1 with a little bit of twist on it. So what is the rule? We can see if you repeat this over and over, and I invite you to try this with, say, 6 cubed, maybe to the 3rd power, and maybe 8 squared to the 5th power. And I want you to do these on your own. You do these using the same method as above. Okay, I'm going to just pause the thing, and I'm just going to write out the answers after you come back from your pause. So pause it, or try just one of them. Okay, so now this would be 6 cubed times 6 cubed times 6 cubed, which is equal to 6 to the 9th. And this would be 8 squared times 8 squared times 8 squared times 8 squared times 8 squared, which is equal to 8 to the 10th. And so you see the rule in all cases is a number raised to a power raised to another power is simply that number raised to the two numbers multiplied. Because this is 2 to the 3 times 2, 2 to the 6. 5 to the 2 times 4, 5 to the 8. This is 6 to the 9th, which is 3 times 3. 8 to the 10th, right? So you should be able to let's try some very advanced problems, or some ones that require you to use the rule. Okay, 5 to the 10th to the 4th would be 5 to the 40th. Now, if you want to pause and break this down, try this one on your own. Pause. Now that you're back after you've paused, we can just write the answer. Is 6 to the 4 times 9 equals 4 to the 36. Good. Well done. So let's look at, I just want to look at another twist that is going to be played, that was played to you if your teacher went through the lesson today. So we're going to make another screen, change our background, and come back. And we're going to draw, let's go to just the little twist. You know, they try to keep you on your toes here with Eureka Math. So I want to show you a question. If you know, now that we know that, say, remember that 3 to the 4th to the, say, 3rd equals 3 to the 12th, right? Because that's equal to 3 to the 4 times 3. So if I wanted to, I can go in the other direction, and I can say that 3 to the 12th is equal to 3 squared to the 6th. Because if I break 12 down, I know that it's 2 times 6. See how I went the other direction? But you could also say that 3 to the 12th is, see if you can figure out some other combinations. It's also equal to 3 to the 6th squared. Now I want you to tell me that what is it if I said it's 3 to the 3rd? What would I have to put inside the box? What goes inside the box if I want this expression to be equal to 3 to the 12th? Okay, I want you to pause and tell me what goes in the box. All right. Well, if you told me that what goes in the box is a 4, give yourself a pat on the back, because yes, indeed, 3 to the 3rd to the 4th power is 3 to the 12th. You know, and I'm going to stop here, and I'm going to say, I just want to show you something that we put up every once in a while, and it's called Happy Cat. And a happy cat is when we kind of have learned a good concept, and we have an answer here that I've asked you to solve. We sometimes put up Happy Cat, and it also gives you a nice spot to stop if you're fast forwarding the video and you want to see that you've been successful. All right, we'll talk more about Happy Cat later on, but let's get moving, and let's go to another. Let's see if we can build on what you just learned here. So let me ask you a question. If I said that this is something that is something they want you to learn in this lesson. If I said y to the 4th is equal to 9, well, there's no number to the 4th power that equals 9 that immediately jumps into our mind. But what if I said if y to the 4th equals 9, then I want to know what y squared equals. Well, you can tell me this, and I'll show you how you can figure this out. And this is a problem that, again, is appears in the lesson. So we're going to go from here, and we're not going to do anything terribly tricky. What does y to the fourth equal? I want you to tell me what y to the fourth can equal. If I said it's equal to y squared, let me write this a little bit neater. Y squared, and what goes inside this box if I want this to be y to the fourth? Y squared to the what power equals y to the fourth. And on the right side, we're going to say we know that 9 is equal to 3 squared. Okay, stay with me. If this doesn't make sense where we're going, I want you to just stay with me. So y squared to the some power equals 3 squared, because we know, again, let me just draw these little circles here, because I know that y to the fourth is going to equal this thing. And we're going to try to make 9. We know that 9 is equal to 3 squared. So if you correct, so pause and see if you can fill in this box. And we'll go forward back in green again. Yeah. So if you told me that this should be a 2, give yourself a pat on the back, because y squared to the second power is y to the fourth. So we're going to write y squared equals 3 squared. And I'm just going to put this 3 in parentheses to highlight a very key idea here. So if y squared squared is equal to 3 squared, then I know that what is inside this box here must be equal to what's inside this box here, because something squared is equal to something squared. And so I know that y squared equals 3, because if y squared squared is equal to 3 squared, I can just say that what's inside here must be equal to what's inside here. And there's actually one little caveat to this, but we're not going to get into that vagary right now. So I answered my question. I don't know what y is, but I know that y squared is equal to 3. And that's all we were asking for. And notice that in the lesson that you have to do a problem like this. So let me ask you another one. So if I said y to the 6th, or let's say y to the 9th equals 8. And I want to know what y cubed equals. So the problem here is we're going to want to make this 8 look like something to a power, and we're going to want to make this kind of match it, the thing on the left. So we know that 8, so we can say here y to the 9th is equal to 2 to the 3rd. Now see if you can, now you try to take this problem and make it look like this problem on the left. So in other words, I'm going to try and make this look like something to the 3rd power equals 2 cubed. And I know that I have to start with this y to the 9th. So I got to make this thing look like y to the something power equals, so something power to the 3rd equals 2 cubed. So now pause and try. Okay, now I hope hopefully you tried this one and you realize that what goes in here, it has to be a 3, because y cubed is y to the 9th, and that equals 2 cubed. So now what's inside, if it's raised to the 3rd power, and what's outside is raised to the 3rd power, then y to the 3rd has to equal 2. And there's our answer. We don't know what y is, but we know that y to the 3rd power has to equal 2. Okay. Now let's move along. Let's move along and let's present the next concept. So let's get a new screen here. Let's get a new background, and let's start Let's go back to blue. Okay, so now we want to learn, now the next thing they present in the lesson is this. They present x, y to the n. They present a rule. And again, these are all variables, and this can be kind of confusing, but they say, well, that's equal to y. Xy to the n is equal to x to the n times y to the n. Well, what does that mean? Let's think of an example of this. So all we're going to do is we're going to plug in some real numbers and see what this really means. So let's say that x equals 2 and y equals 5 and then n equals 3. We're just going to plug in some numbers. So we use variables to basically say that any number plugged in will make, any numbers plugged in for variables will make this thing work as long as we keep that same number assigned to the variable throughout the problem. So let's say if x is 2, then let's just copy this over and we'll say, well, that's 2. X is 2. Y is 5, so let's say times 5. To the n is 3. Well, we know that that is going to have to equal 2 to the third times 5 to the third. Now, can we prove this? Can we prove this? Yes, we can. We can prove this using all of our rules that we've learned in lesson 1, earlier in lesson 3, and then our commutative property of multiplication, which we learned in 7th grade. So let's watch how we do that. And you're going to need to know this. This is key. You need to know this for the homework. So keep your eye out. You're going to need to know how to do these kinds of proofs. So 2 times 5 to the third is equal to 2 times 5. It multiplied 3 times. 2 times 5 times 2 times 5. That's what a power means. What's inside multiplied by this by itself this many times. Well, we know that that is equal to 2 times 5 times 2 times 5 times 2 times 5. We can just remove the parentheses because everything is multiplied. So we can just multiply it, right? Everything's multiplied. We can regroup. We can remove parentheses as long as there's all multiplication. And now we can use our commutative property. So we can just rearrange. We're going to put all these guys together. And we say, well, that's 2 times 2 times 2 times 2. And then we're going to put all these guys together. Times 5 times 5 times 5. All the same thing. And 2 times 2 times 2 is equal to 2 to the third power. And that equals, and 5 times 5 times 5 is equal 5 to the third power. Right? So we just proved that 2 times 5 all to the third power is equal to 2 to the third times 5 to the third, because we started here and we went here, we went here, we went here, and we went here. So if we started here and got to here, we know that those two are equal. So you're going to need to know how to do these proofs on your homework. So in general, what you need to know is that anything times anything else to a given power is just equal to that power times the other number to that power, right? These are both examples of this rule. Here, this is example 1, and this is example 2. And you can prove this on your own. I'm not going to show you this proof, but you would do it in the exact same way as we proved the 2 times 5 to the third rule. Now, more generally, I want to show you one other thing. More generally, I want to show you that if you have something, a number to a given power, and another thing to another power, all of it raised to a power, you can simply multiply your numbers, your exponents, and get your answer. So this is 3 to the 10th times 4 to the 15th, right? Just like 3 squared to the 5th equals 3 to the 10th, which we learned earlier this lesson, and 4 to the 3rd to the 5th equals 4 to the 15th. When you put those two together inside parentheses, you can do the same thing with your exponents. You just multiply. Think of it as multiplying, you multiply down. With exponents. Okay, when you have a product inside parentheses and you raise that to a power, you can just multiply your exponents. So I want you to try these ones. I'll give you two examples. 9 cubed times 40 to the 3rd, or no, we won't do that one to the 3rd. We'll do that one to the 4th. All to the 10th equals what? And then x squared times y to the 4th cubed equals what? So pause and try, and I'll give you the answers. Okay, so this would be 9 to the 30th times 40 to the 40th. And this would be x, right? We're going to take the 3 and multiply it by your 2 and by your 4, and we get x to the 6th, y to the 12th. And what we'll do here is we'll go happy cat. Happy cat on those answers if you got those right. Good. Okay, one last thing we want to show. One last thing I want to show you before we go on to a little bit of homework help is the idea of x over y and this is going to be very similar to the last rule, right? And let me prove the answer, and then we'll show you the answer at the end. We'll show you the rule. So we're going to prove the rule, then I'll show you the rule. We'll do it a little backwards than we just did. But the same thing we're going to do. We're going to use our rules of exponents to expand this fraction that is raised to this power. We're going to say, well, what does it mean for a fraction to be raised to a power 4? Well, it means you're going to multiply that thing 4 times. So this is no different than anything we've been doing so far. We're just going to raise that thing. We're just going to multiply that thing 4 times. Well, and now we know the rule. Remember, if we just multiply a fraction, let's say a simple fraction 4 times, what do we do? Well, we multiply those numerators, and we get, 16. And we multiply those denominators, and we get 81. Well, we do nothing different here with our exponents. X squared times x squared times x squared times x squared times x squared is x squared times x squared times x squared times x squared. And on the bottom, we get y cubed times y cubed times y cubed times y cubed. And we know from earlier in this lesson and from the prior lessons that is equal to x to the 8th, x squared times x squared times x squared times x squared. We're just adding exponents. We add our exponents. And down here, we're going to add exponents too. It's equal to y to the 12th. And so you can see the rule applies. The same rule applied if we were to say, x squared, y, x to the 2nd, y to the 3rd, to the 4th, and we do our multiply down, x8, y12. we just do the same multiply down, even if we have these as fractions. We just multiply down because our answer is x to the 8th over y to the 12th. So the rule is, x to the n over y to the m, all to the, r power is equal to x to the n r over y to the m r. You just multiply these things. So let's try a few. Here, I'll put these problems in. We'll put them in now. We'll put them in orange. So 2 to the 4th over 3 to the 6th, all to the 2nd equals what? And then we'll do, x to the 3rd over y to the 10th, all to the 5th power. What does that equal? And then we'll do an advanced one. How about this? X, y squared over 3, all to the 5th power, just to see if you can make that one work. Okay, so now pause and try. Okay, I assume you've tried these. So this is going to be, we're just going to draw our arrows. Draw our arrows and multiply down, and we get 2 to the 8th over 3 to the 12th. Draw your arrows. Here we get x to the 15th over y to the 50th. And here we have 3 arrows. Well, what is this hidden exponent right here? We haven't really covered it, but x, this is like an x to the 1. So our answer is going to be x to the 5th, y to the 10th, over 3 to the 15th. If you got that one, give yourself a big pat on the back. And we'll go with, we'll do a happy cat, and if you got this one, give yourself a big happy cat. That is awesome. So this is lesson, this was lesson, 3 or 8 in 1, lesson 3. I'll give you a little bit of homework. I mean, the homework help, we've kind of covered it throughout the lesson. How do you prove that this is equal to this? This is going to be kind of your homework question. How do you show that? And the way you show it is with all these intermediate steps. So every page along the way has been showing you how to do the homework. But let me give you one more homework help for the hard one, which is the last homework problem. Let's do that right now. And I'll just give you something to whet your appetite. It won't give you the final answer, but if you have to show that y squared, that y to the n to the m is equal to y to the n m. The way that you show that is you can't draw something y to the n times or y to the m times, so you do it like this. You go y to the n times y to the n times y to the n dot 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 y to the n, and you say, this is the informal way to make a proof, but it's a good way to make a proof. You say that's m times, right? Because y to the nth power to the mth power, I have to draw this thing m times. So what I do is I say, well, I don't know how many m is because m is a variable. So I'm just going to draw a few y to the n's and put a dot 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 y to the m, and I'm going to say, well, I do that m times. And so that would be equal to, y to the n plus n dot dot dot, and then you'd say m times. Well, if I have n plus n dot 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 n times m times, that's, you know, m times, that's equal to m times n, right? Because if I had 3 times 3 times 3 dot dot 3, and I had that 10 times, right? Sorry, these are pluses. And I had that 10 threes, that would equal to 10 times 3, or 30, right? If I had 3 plus 3 10 times, that's equal to 30, or 10 times 3. So if I have n plus n plus n, m times, that's equal to y to the m n. And we'll leave it there. Okay. Good. So we're back. Let's see. Back here. I just want to say bye. You know, that lasted, I don't know, maybe 20 to 30 minutes. We'll see. Hopefully this was helpful. Hopefully if you, again, you can use the homework help by skipping to the end of these videos. You can just watch me work some of the problems that you had, or the parts of the lesson that you may have had difficulty with in class. If you missed class, maybe this would serve as a substitute for part of the lesson. I don't go into as much depth as your teacher may have done in class. That's not the full intent here, but it is to help you. It's really to augment those lessons, and maybe to serve as a substitute every once in a while, as well as to connect the lesson through to the homework. And I'd love it if you gave me a thumbs up on YouTube if you like this, or give me some comments if you either liked it or need some improvement. I will be with you back on lesson 4. Keep an eye out. Keep connected. Follow me. Good if you give me a follow. Love it. And we'll talk to you later. Over and out.